It really feels like we're navigating a tidal wave of new information these days. I mean, every sector is buzzing with innovations, and it's a real challenge to cut through the noise, to understand the core trends without getting completely overwhelmed.
That's absolutely the crux of it, and that's exactly what we want to do here. Today, we're diving deep into a technology that's, well, generating a lot of buzz and holds immense potential. Blockchain and distributed ledger technology, or DLT.
Right.
Our goal is really to move past the hype, the jargon, and uncover the fundamental insights from a range of different sources.
Exactly. And we've pulled together a really interesting set looking at DLT in healthcare, real estate, supply chains, even legal frameworks, and the insurance sector. Think of this as your shortcut, maybe, to grasping the real capabilities and, well, the current state of play for this technology across these fields.
A useful map through the complexity.
Yeah. So to start us off, what exactly are we talking about when we say DLT? Let's establish the basics.
Okay, let's unpack that. So at its core, a distributed ledger is essentially a database. But the key difference is it isn't held in one central place.
Okay.
Instead, it's spread out, replicated across a network of computers, nodes, as they're called.
Love it. Contrasting with traditional systems.
Precisely. Those traditional centralized systems, they can have single points of failure, be vulnerable to cyber attacks in a concentrated way. DLT tries to mitigate that.
So does that mean everyone on this network has an identical copy of the database?
It's exactly right. Each node maintains a perfect replica of the ledger, and the system is designed for constant synchronization, keeping all copies updated.
How does new information get added then? Securely.
Ah, that's where it gets interesting. New info, like transactions, is verified and added through what are called consensus mechanisms.
A consensus mechanism.
Yeah, essentially they are agreed upon rules. The network participants follow these rules to validate every new addition before it gets added to the shared record. There are different types, but the core idea is this distributed agreement ensures legitimacy.
That sounds like it could fundamentally change how we think about trust and security online.
It certainly has that potential.
Now, I often hear public and private blockchain mentioned. What's the main difference there?
That's a really critical distinction. So public blockchains, think Bitcoin or Ethereum, are open. Anyone can view the ledger. Anyone can verify transactions. Anyone can potentially participate in the network itself.
Completely open.
Right. Private, or sometimes called permissioned, blockchains are more controlled. They restrict who can join, who can see what data, who can validate transactions.
Okay, so more like a members-only club.
Kind of, yeah. And this offers certain advantages, especially for businesses. You get greater control over data privacy, potentially better scalability sometimes because fewer participants are involved, maybe faster transaction processing.
I can see why that would appeal to certain industries.
Absolutely. You see consortia, like in banking, for example, often leaning towards private blockchains for exactly those reasons.
Makes sense, especially with sensitive financial data. Now, DLT and blockchain, they're often painted as inherently trustless and super secure. Is it really that straightforward? Are there nuances?
Yeah, this is where we need to dig a bit deeper. That term trustless. It's used a lot, but it's maybe more accurate to say the trust is shifted.
Shifted how?
Well, you still need to trust the underlying cryptography, the map that secures the whole system. And importantly, in private chains, you're placing significant trust in the organizations that manage and operate that network.
Right. So trust hasn't vanished. It's just placed differently.
Exactly. And think about the Ethereum community split the fork that created Ethereum Classic. That shows that even in these systems, disagreements about the rules or history can happen, leading to splits. Trust in the community or governance is still relevant.
Okay, so not a complete elimination of trust. What about data accuracy? Does the blockchain guarantee the information put onto it is correct?
That's another crucial point. Blockchain is brilliant at validating transactions based on preset conditions. It checks if the rules of the transaction were followed. But it absolutely cannot assess the accuracy of the initial data input.
So garbage in, garbage out still applies.
Pretty much. If someone enters flawed information initially, the blockchain will faithfully record and validate transactions based on that flawed data, following its rules perfectly.
And security. Is it truly unhackable? We hear about immutability.
Well, the distributed nature definitely enhances security compared to a central database. It's much harder to tamper with. But it's not completely foolproof.
How so?
Private keys, the digital keys that control your assets on the blockchain, they can still be stolen or lost, just like a password. And the networks themselves can be vulnerable to certain types of attacks, like eclipse attacks or the well-known 51% attack, where one entity gains majority control.
A 51% attack. That sounds serious.
It is, though typically very expensive and difficult to pull off on large established public blockchains. And even immutability isn't absolute dogma. Theoretically, transactions could be reversed if a large enough portion of the network colluded to agree on a change.
But that would be incredibly difficult.
Extremely difficult and highly unlikely on major networks, as it undermines the very trust the system is built on. But theoretically, the possibility exists. It's not magic.
That's a really important reality check. Okay, so we have a better handle on the tech itself now. Let's explore some practical applications. Real estate often comes up. It's an industry that feels, well, ripe for some modernization.
Absolutely. You look at current real estate deals, they're often incredibly lengthy, costly processes.
Oh, yeah. Lawyers, agents, lenders, appraisers, so many steps.
Exactly. Multiple intermediaries, and data is often stuck in separate private silos, not standardized. This fragmentation also just opens the door for human errors.
So how does DLT promise to help there?
The idea is to use DLT to create a more efficient, transparent process. Imagine having openly accessible, up-to-date, standardized property information all in a single shared pool.
A single source of truth for property data.
That's the vision. It
Yep.
could streamline things significantly.
Okay, how might that work practically? I've had buzzwords like smart contracts and tokenization. Can we unpack those in the real estate context?
Sure. Let's start with smart contracts. Think of them as self-executing digital agreements. They're basically scripts, lines of code living on the blockchain.
Code that acts like a contract.
Precisely. They automatically execute the terms of an agreement when certain predefined conditions are met. For example, automatically releasing funds when ownership transfer is confirmed on the ledger.
So it could cut out some of the manual steps and checks.
Exactly. It reduces the need for some intermediaries and can minimize the risk of disputes or even malicious behavior because the execution is automatic and transparent based on the code. Blockchain is really the technology that makes these feasible on a wide scale because it provides that trusted, auditable platform.
Interesting. That sounds like it could really speed things up. What about tokenization? That sounds more radical.
It is quite a shift in thinking. Tokenization basically involves representing ownership rights in a real estate asset, like an office building maybe, or even a piece of land, as digital tokens.
Like shares in a company, but for a property.
Very similar concept, yeah. These tokens could then potentially be traded on specialized crypto exchanges. Proponents suggest this might offer a faster, perhaps easier way to raise capital compared to traditional routes like REITs or IPOs.
But maybe with less paperwork or regulation initially?
Well, that's part of the discussion. Currently, the disclosure requirements aren't always as stringent, which is both a potential benefit for speed and a potential risk for investors.
What are the other potential upsides?
The big ones mentioned are increased liquidity, making it easier to buy and sell stakes in assets that are traditionally very illiquid, like large commercial properties. And related to that is fractional ownership.
Meaning you could buy just a small piece of a building?
Exactly. It could allow more people to invest in high-value real estate that they couldn't afford otherwise.
Yeah.
It sort of democratizes access, potentially. But it fundamentally changes how we view property ownership, moving from large, indivisible chunks to potentially tiny, liquid pieces.
Fascinating. But there must be downsides or risks.
Oh, absolutely. A big one is volatility. The value of these property tokens could fluctuate based on crypto market sentiment, potentially quite independently of the actual value of the underlying building. They might behave more like tech stocks than stable real estate.
So the link to the physical asset might be weaker than expected.
It could be, yes. And there are significant legal complexities too, especially around enforcing the rights embedded in those smart contracts and tokens across different jurisdictions. How does the token legally represent ownership? It's still being worked out.
Is there much confidence this will actually take off?
Opinions are mixed. One survey suggested about 65% thought widespread adoption in real estate was likely in the next 5 years, but that leaves a significant 35% skeptical. And we've seen real-world hurdles like the canceled Harbor token offering for a student residence. The mortgage provider wasn't on board.
Right. The existing financial infrastructure needs to adapt too.
Exactly. And interestingly, some sophisticated investors might not even want more liquidity. Part of their strategy might rely on real estate being relatively illiquid compared to stocks.
So not a silver bullet. You also mentioned property valuation using DLT. How does that work?
Yes, there are some interesting pilots here. The Bank of China in Hong Kong and JLL, the real estate services firm, they've explored using blockchain for appraisals.
How?
Essentially, a surveyor uploads their valuation report to a distributed ledger. The system creates a unique hash. Think of it like a digital fingerprint for that specific report.
Okay, a unique identifier.
Right. If anything, the report changes, even a comma, the hash changes completely. So this hash, along with key property details, gets stored on the blockchain. Participating banks can then access this info and use the hash to instantly verify that the report they're looking at is the original untampered-with version submitted by the surveyor.
Ah, so it ensures authenticity and integrity.
Exactly. It makes the process more transparent, cuts down on paper, reduces potential errors, and makes fraud much harder.
That sounds like a very practical, clear benefit. What about land registries?
That's another big idea being explored. The concept is a blockchain-based registry storing all land ownership records, perhaps managed via smart contracts. A single, immutable source of truth for who owns what.
Wow, that sounds revolutionary, but also hugely complex to implement, requires massive coordination, right?
You've hit the nail on the head. The social and political hurdles are immense. You need buy-in and coordination from government agencies, regulators, the entire industry. Plus, overcoming the general lack of deep understanding of the tech is still a barrier.
And the public versus private chain question must come up here too. Privacy is obviously key with property ownership.
It does. And yes, most current real estate DLT pilots do use private permission networks precisely for that reason, control over data access.
But as you said, private chains have their own trade-offs.
They do. They introduce their own potential vulnerabilities,
Right.
risks of hacks, internal manipulation, and they arguably move away from that core decentralization principle that makes blockchain interesting in the first place.
It always seems to be a balancing act. Now, there's this debate. Is DLT truly disruptive in real estate, creating totally new ways of doing things, or is it more of a foundational technology that will just improve existing processes?
That's a key strategic question for the industry. Some frameworks, like Christensen's theory of disruptive innovation, suggest DLT could spawn new markets, maybe simpler, cheaper property investment products that attract new customers and eventually challenge incumbents. But others, perhaps drawing on Mark Addy's ideas about business model innovation, argue it's more likely DLT will primarily redefine how existing services like brokerage, lending, or registry are delivered, making them more efficient, more transparent.
So changing the how rather than the what?
Potentially, yes. The big challenge, though, is that even just changing the how with DLT can create significant conflicts with established business practices and revenue models. It forces existing players to make tough choices.
I can imagine. Is there a way to categorize these potential changes?
Yeah, one useful framework looks at blockchain adoption in real estate across two axes: novelty, how new the idea is, and coordination, how many different parties need to work together. This gives 4 phases.
Okay.
Phase 1 is single use.
Yeah.
Low novelty, low coordination needed, like that blockchain-based evaluation example we discussed. Phase 2 is localization.
Yeah.
High novelty, but still limited users, maybe a private network connecting just a few companies. Phase 3 is substitution. Lower novelty, but requires high coordination. Think about something like a standardized digital identity system for everyone involved in property transactions.
Yeah.
And phase 4 is transformation. High novelty and high coordination, leading to really wide implications. Maybe truly automated, self-executing contracts for complex property transfers.
That framework really helps visualize the different levels of ambition and difficulty. Okay, let's switch gears. Supply chain management, another area that seems tailor-made for DLT, given all the complexity and moving parts.
Absolutely. Think about global supply chains today, incredibly complex, involving numerous companies, countries, modes of transport. Tracking goods and verifying their condition reliably is a massive challenge.
So how does blockchain help there?
It can create that tamper-proof, decentralized record of every transaction, every movement, every handover. This makes it significantly easier to track goods accurately and verify their condition from origin right through to the final consumer.
So it's about creating a shared, trusted logbook for the product's journey.
Exactly. A single, shared version of the truth that all participants can access and rely on.
What are the main benefits of that?
Well, shared access to authoritative data builds trust between partners. It helps prevent fraud, counterfeit goods, for instance. It can minimize disruptions and errors because everyone sees the same picture. And if something does go wrong, say a temperature fluctuation for sensitive goods, it's much easier to pinpoint exactly when and where it happened.
And can it link up with other technologies, like scanners or sensors?
Yes, that's a key aspect. DLT platforms can integrate with existing tech like barcode scanners, RFID tags, even IoT sensors monitoring temperature or humidity. There's also potential to link it with digital identity systems for verifying who handled what when.
And I assume smart contracts fit in here too.
Oh, definitely. Smart contracts and supply chains can automate actions based on agreed terms. For instance, automatically triggering a payment when sensors confirm a shipment arrived at a location within the agreed temperature range.
Reducing disputes about milestones and conditions?
Precisely. It takes some of the ambiguity and potential for disagreement out of the process.
So better transparency, better traceability, automation. It sounds like a strong case for efficiency gains.
It really does. That immutable ledger showing every step provides transparency, and it's accessible to everyone authorized. Now, to really understand the economic drivers here, it's useful to look through the lens of transaction cost economics, or TCE.
Okay, TCE. What does that tell us?
TCE basically looks at the costs involved in making any economic exchange or transaction. It considers things like bounded rationality, meaning we can't know everything, and the potential for opportunism or self-interest.
Right, the classic economic assumptions. How does DLT change that equation?
Well, DLT seems to introduce several interesting effects according to TCE analysis. First, there's the DLT enhanced assistance effect.
Assistance effect.
Yeah, the technology provides better information, verified, reliable, traceable data, often combined with AI or smart contracts. This helps managers make better decisions, reducing costs associated with poor information.
Makes sense. Better data, better decisions.
Then there's the DLT enhanced substitution effect. The idea here is that the increased transparency DLT enables can actually build trust between partners. If trust increases, the perceived risk of opportunism might decrease, potentially lowering transaction costs related to monitoring or complex contracts.
So transparency fosters trust, which replaces some need for costly oversight.
That's the theory. There's also a DLT-enabled demonopolization effect. Because third-party developers can create DLT solutions, often without needing direct access to the sensitive transaction data on the ledger, they're less likely to become information monopolies themselves.
Interesting. What else?
We see a DLT-caused network effect. DLT solutions often create specific networks for particular supply chains or industries. This is great for those inside the network, but it can lead to problems of incompatibility between different DLT platforms until we see some consolidation or standardization.
Silos again, but maybe digital ones this time.
Could be, initially, yes. Then there's the DLT-enhanced automation effect. We talked about smart contracts. DLT's ability to verify conditions allows for automated monitoring and enforcement, reducing the costs of managing agreements after they're signed, what TCE calls ex-post coordination costs.
Okay, mostly positive effects so far.
But there's also the DLT-caused torpedo effect.
Torpedo effect, that sounds less good.
It can be. The same transparency that builds trust can also reveal a partner's weaknesses or inefficiencies more clearly. If your performance isn't great, and everyone can now see that on the ledger, you could lose bargaining power.
Ouch. So transparency cuts both ways. It could destabilize existing relationships based on previously hidden information asymmetry.
Exactly. It highlights a real tension. DLT promises efficiency via openness, but that very openness could disadvantage players who relied on keeping certain performance aspects private.
So summing up the TCE view on supply chains.
It suggests DLT can increase asset specificity, making relationships maybe stickier, and create fear of losing power due to transparency, while also enabling automation and potentially reducing costs. So it's a mix of benefits and potential downsides that companies really need to weigh carefully.
That's a fascinating economic perspective. Okay, let's shift again to the legal and regulatory side. It often feels like the law is playing catch-up with tech like this.
You're absolutely right. The legal landscape for DLT is definitely still evolving. And part of the challenge is just the sheer diversity of DLT systems out there, permissionless, the different kinds of digital assets they handle, whether it's cryptocurrency or a digital representation of a security.
Oh, requiring slightly different legal thinking.
Potentially, yes.
Right.
A major headache is legal uncertainty, especially around ownership rights. What does it mean to own something on a blockchain legally? And how do you handle transactions that cross borders?
Right, because these digital assets don't really have a physical location like a house or a gold bar.
Precisely. Determining the lex situs, the governing law based on the asset's location, is a fundamental problem for traditional legal frameworks when applied to inherently digital, potentially borderless assets.
Has there been any progress on figuring that out?
Well, for traditional securities held through intermediaries, the Hague Securities Convention proposed the prima principle. It basically says the governing law is the law of the place where the relevant intermediary's account is maintained.
Okay.
A variation, prima plus sic, puts more emphasis on an express agreement about governing law between the account holder and their intermediary.
Can we just apply that directly to DLT systems?
It's tricky. One idea is elective situs for DLT, letting the network participants themselves choose the governing law for the entire system within the system's rules or code.
But how would that be enforced globally?
That's the challenge, enforcement across different legal jurisdictions and getting regulators everywhere to agree. Another approach is to look at the chosen law of the transaction itself. Each transfer on the DLT could be governed by a law chosen by the parties involved, aligning with existing rules for intangible assets. But that could become incredibly complex to manage for every single transaction.
Seems impractical on a large scale.
It could be. A final idea floated is lex codicis, looking to the governing law of the actual software code that creates and runs the DLT system.
Governing law based on the code itself.
Yeah, it's another theoretical approach.
So lots of ideas, but no single clear answer yet.
There isn't one universally accepted answer, but the consensus seems to be leaning towards the idea that selecting a governing law, perhaps through a combination of participant agreement and system design, is feasible for most DLT systems. And that this, combined with smart, flexible regulation, is probably the most efficient way forward to reduce that legal uncertainty.
Okay, that makes sense. Now, our sources also mention the insurance sector, specifically this concept of open insurance. What's that about? Is it related to DLT?
It's related in the sense of leveraging data and technology, though not exclusively DLT. Open insurance basically wants to apply the principles we've seen developing in open banking to the insurance world.
Meaning sharing customer data.
With consent, yes. The idea is to allow authorized third-party providers, TPPs, maybe tech startups or comparison sites, to access customer insurance data via APIs, but only if the customer explicitly agrees.
What's the potential benefit for me, the consumer?
Potentially, you could get more personalized insurance products, maybe better prices, because TPPs can analyze your data with permission to offer tailored quotes or find better deals. For insurers, it could open up new distribution channels and spur innovation.
Sounds interesting, like comparison sites, but with deeper access. But what are the risks? Insurance data feels pretty sensitive.
Absolutely. Data privacy and security are huge concerns. What happens if data is misused? What if there's a breach? There's also a lack of standardization right now in data formats and APIs, making it hard to implement smoothly. And critically, you need a really clear framework around data rights.
Like, what exactly am I consenting to? How do I revoke consent? What happens if something goes wrong?
Exactly. You need clear rules on consent, easy ways for consumers to seek redress if there's a problem, and a common liability model: who is responsible if data is misused or lost.
Is this actually happening? Are there regulations?
It's still very early days. There are no universal binding rules for open insurance yet. Some countries or regions are discussing it, consulting on it, maybe have some early pilot projects. But there's a general agreement among regulators, like those in the IAS FinTech Forum, that a proper regulatory framework is needed to protect consumers and ensure data is used ethically.
So lots of discussion, less concrete action so far.
Pretty much. And there are barriers. Big insurance companies often have old legacy IT systems that make data sharing hard. They worry about privacy risks. TPPs find it difficult to partner with these large incumbents.
What could help bridge that gap?
Well, things like reciprocal data audits between insurers and TPPs could build trust. But honestly, a major barrier right now is just lack of consumer awareness. Most people haven't even heard of open insurance, so there's little demand driving it forward yet.
And where does DLT fit into insurance more broadly? Is it just about open insurance?
No, insurers are exploring DLT for other potential benefits too. Things like increasing efficiency, especially in complex areas like reinsurance processing claims and contracts between insurers. There are consortia like B3I that have worked on this. Reducing fraud is another potential application.
But regulators are watching closely.
Yes, alongside the potential benefits, regulators are very aware of the risks, operational risks, if the tech fails, cybersecurity threats, and ensuring consumers are protected, especially if complex DLT-based products emerge.
Okay, wow. We've really covered a lot of ground. The tech basics, real estate, supply chains, legal issues, insurance. Stepping back, what are the big overarching themes or considerations we should keep in mind?
Well, I think the main takeaway is that while DLT clearly offers significant potential for more efficiency, greater transparency, new types of innovation across many sectors, it's not magic. It still faces real technical hurdles.
Like scalability, you mentioned.
Scalability, yes. Confidentiality is still a challenge in some contexts. Interoperability, getting different blockchain systems to talk to each other, is a big one. And security vulnerabilities, as we discussed, are real. Governance, who makes the rules for these networks, is also a thorny issue.
And requires cooperation.
Absolutely essential. Real progress requires collaboration between the industry players, the regulators, and researchers in academia. Fostering responsible innovation while managing the risks needs everyone working together.
And you mentioned earlier that connection between the digital DLT world and the physical world. That seems like a recurring challenge.
It really is. That interface is maybe one of the weakest links, especially for things like real estate or supply chains where you're dealing with physical assets and legal rights tied to the physical world. How do you reliably link a digital token to a physical barrel of oil or a specific apartment? It's not trivial.
Yeah, the Oracle problem, as it's sometimes called.
Exactly. And finally, it's just important to recognize that adoption isn't uniform. Confidence levels and maturity vary hugely depending on the specific application and the sector.
Like you said, maybe more confidence in smart contracts for simple automation than full-blown tokenization of everything right now.
Precisely. Or in insurance, using AI for claims processing might be further along than figuring out AI fairness in underwriting, which is still a very nascent field. It's a patchy landscape of progress.
Not a single tidal wave, but lots of different currents moving at different speeds.
That's a good way to put it.
Well, this has been an incredibly illuminating deep dive. We've really unpacked DLT's core ideas, looked at how it might reshape real estate and supply chains, wrestled with the legal questions, and seen its emerging role in areas like insurance via open data.
And the recurring theme, as we've seen, is this mix of genuine promise for efficiency, for transparency balanced against real challenges, technical limits, security worries, legal gray areas, and crucially, the need for collaboration and also just better understanding, both by industry and by consumers.
Definitely. So here's a final thought to leave you, our listener, with. Given all these complexities, the different speeds of adoption we've talked about, which specific areas of DLT application do you think will actually have the biggest impact on our daily lives in the next, say, 5 years? And maybe more importantly, what are the biggest hurdles you see that need to be cleared to make that happen?
That's a great question to ponder.
Definitely something to keep exploring and thinking critically about as this technology continues to evolve.